Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate some of the options we have inside Toolbox on this part. If you take a look at this part, you can see we have samples of every single option that we have in Toolbox, but we're only going to go through several of them just to give you an idea of exactly what Toolbox actually is. Now, I'll start off by opening up the operation that does this wide slot over here. If I were to open up the operation itself, you can see that we have the option over here taken from all of the different options available within Toolbox itself. And this one is called Additional Zigzag, as shown over here, where the tool will go down in a zigzag fashion in the middle, clean the middle, and then work around the sides as shown in the diagram itself. The geometry is the border around the slot itself, and the tool will be a 10 millimeter end mill. Levels going down to the floor over here of 10 millimeters, and in the technology we have our step down, our ramping width as far as how wide of a ramp do we want as we're going down, and the maximum angle for the ramp itself. Then we also have our parallel cuts as said over here, showing the step over between each cut around the wall itself. Taking a quick look at the simulation, you see that the tool will go down, zigzag according to the dimensions we gave it with the proper angle, then do a cut across the part, and then start its parallel cuts around going towards the wall itself. Now let's go to our next operation where we'll be doing a simple slot over here. If I were to open up the operation, you can see that we use the option of simple slot from all of our options as shown over here, where all we have to do is choose these two lines as our geometry as shown over here. The tool that we'll be using will be the 10 millimeter end mill, going down 10 millimeters, and in our technology we just have our step down, and we have the possibility of wall and floor offset, and extension is how much you want to actually go past the part itself. Taking a quick look at the simulation, you'll see that the tool goes down, goes across that wall, goes back, down to the end without jumping up at the end over there. Now, in our next operation, we have a completely closed slot where the tool will be the exact diameter as the width of the slot itself. So if I were to open up the operation itself, you'll see we'll be using the option of closed slot as shown in the geometry over here. And the tool, as I said, will be the 10 millimeter end mill, which is the exact width of this area over here. Levels to the bottom, and in our technology, we'll have a step down of every 2 millimeters as we go down on the part itself. Taking a look at the simulation, you'll see that the tool will go down, and as it goes towards across, it also works its way towards the bottom, stepping down the amount I asked it to step down each time. When it gets to the bottom, it does one cross step to clean the bottom itself. Now let's jump over to this operation over here, to this area over here, where I'd like to clear off this corner area, this entire floor over here. So if I were to go into the operation, you'll note we chose the option of simple corner from all of our options over here. The geometry in this particular case is just this line itself, nothing else, and note the direction of the line as well. The tool will be the 10 millimeter end mill, and if we go into our technology, all we have is our step down, the amount of step over we need, and wall set and floor offset also if necessary. Taking a quick look at the simulation, you'll see the toolpath is automatically done so that it works exactly on that surface without going out any excess amount of material over there, just taking the exact amount that we need according to the shape of the surface, according to this corner. This corner was closed automatically. Now let's jump over to this operation where we'll show the use of O-ring on this area over here. If I were to open up the operation itself, we chose the option of O-ring from all of our options. Our geometry are the two chains over here, the outside circle and the inside circle. The tool will be a 4mm end mill, which is less than the width of the O-ring itself. And we have our levels going down a total of 5mm. In our technology, we have our rough cut and our finish cut, where our rough cut will be stepping down every 1mm, going down in a spiral motion into the pocket itself, in the middle of the part. And our finish cut will then work on the entire wall itself, on one wall and then on the other wall. And if we want, we can have a step down, how much we want it to go down on the wall itself. We'll just leave it the way it is and take a look at the simulation. You'll see that the tool will go into the part, doing a spiral cut as it goes down in the middle of the part itself. And then when it gets towards the walls, it'll finish the wall on one side and then finish the wall on the other side as well. Now we'll jump over to our last operation where we will be doing a spiral cut inside the pocket itself. If we take a look at the operation, we have spiral cut. This is meant for a circular pocket. As you can see in the geometry, also shown over here on the part itself, we'll be using a 10mm end mill going down a total depth of 10mm. If we take a look at technology, we just have our step down itself, minimum cutting angle and maximum cutting angle, and the helical angle itself as it approaches inside the circular pocket. If we take a look at our simulation, you can see that the tool actually does a helical cut into the pocket itself and then works around in a spiral motion around the bottom of that part, finishing it off using the spiral cut inside the pocket. For more videos on SolidCAM Professor, please go to our website www.solidcam.com and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.